Amchi, Mumbai is home to millions of people and a land of opportunity. To serve Mumbaikars, our vibrant city boasts of a highly penetrated land transport system consisting of roads and railways. But with the ever-increasing population, there is considerable stress on the existing infrastructure leading to congestions and traffic vows. With a view to reduce commuter inconvenience, MSRDC has come up with an elegant solution of creating a seaway system around the island city by constructing passenger water terminals at 9 different locations. Among these locations, Bandra has been identified as one of the locations for constructing the passenger terminal. The Bandra port would be jointly developed by Supreme Infrastructure, a leading name in infrastructure development across India, and Dbm Geotechnics and Constructions Private Limited. A company with over 20 years of expertise in providing sound geotechnical construction services to over 2,500 civil engineering projects. The passenger water transport terminal will be located near the Bandra-Worli Sea Link Bridge, and the project would be completed in 546 days. The broad scope of work would include piling operations to lay foundation for the jetty and the terminal building of Bandra Port, carrying out dredging works around the proposed site, strengthening and extension of the existing breakwater, construction of a state-of-the-art terminal building and parking spaces outside the building, creating approach roads around the proposed site to allow swift access to the new port, construction of link span and floating pontoons for up to 6 catamaran boats and a hovercraft port. Many of these activities would be carried out simultaneously by the joint venture so that the project is completed well in time and handed over to the MSRDC. Once complete, the Bandra port is estimated to serve 2 lakh commuters, handling 500 ferries daily, thereby forming a key solution in resolving the traffic vows of Amchi, Mumbai. Let us now understand how Supreme Dbm would turn this exciting new port into a reality. Survey and mobilization. As a first step, the Supreme Dbm joint venture would do extensive survey of the proposed site, researching and collecting data, performing geotechnical investigation of soil, and make amendments in the design based on analysis of the data collected. These extensive surveys would allow us to mobilize the right kind of materials, equipments, and personnel to carry out the construction activities. Simultaneously, a project wall would be constructed around the periphery of the project to secure the proposed site.
Precasting yard. For the storage of construction material and carrying out precasting jobs, an area of around 1.5 acres, which is within 1 kilometer of the site, will need to be provided by MSRDC. This space will be used as storage and laydown area for casting of the blocks, stocking of supplies, stacking of pipes, and setting up a construction site office. Piling. Piling is the process of driving steel or concrete piles into the ground to transfer the load of a building or structure to deeper soil or rock of high bearing capacity, thereby providing support to a structure. Piling would form a crucial step in the construction of the Bandra port, and the process would commence from the 4th month onwards. Various equipment such as gantries with 4 winches, crane barges, vibro hammers, diesel winches, tugboats, concrete pumps, among others, would be deployed for laying the pile foundation. Piles would be fabricated on site and transported to the gantry using cranes. Temporary piles will be driven at the appropriate location using vibro hammer to support erection of piling gantries. 4 such piling gantries with 4 winches each will be erected to allow piling to be carried out at multiple locations. Once a set of piles are driven, the gantry would move forward to place the next set of piles into the ground. The piles would then be chipped and fixed with piles caps. Pile caps would be connected together using beams forming a mesh of concrete and steel. Concrete pumps would carry out in situ concreting, and then the deck slab would be laid on the pile foundation. The piling gantries would move from west to east and thus lay the foundation for constructing the jetty and the terminal building. The entire piling work is slated for completion in 314 days, and the process would overlap with other activities such as dredging and breakwater construction.
Dredging. The side of the Bandra port is surrounded by shallow waters which can hinder the movement of larger boats during low tides. Hence, the seabed around the port would need to be excavated to deepen the harbour by up to 12 feet. This underwater excavation is called dredging. We would carry out the dredging operations using excavators and grab dredgers, which have clamshell buckets attached to a crane mounted on spud barges. These dredgers would excavate the bay mud and load it on bottom opening hopper barges, BOHB. Once filled, these hopper barges would be towed away to the disposal location by tugboats. This disposal location would be at least 35 kilometers from the proposed terminal. On reaching the disposal location, the bottom of the hopper barges would be opened to dispose of dredging material. Multiple hopper barges would be deployed to carry out round-the-clock disposal of dredged materials, and the entire dredging operation would be completed in 300 days.
Breakwater. The Arabian Sea can get quite rough at times, causing damage to unsecured property on the seafront. Hence, in order to protect the new Bandra port and the anchored catamarans from the pounding of the waves, an underwater seawall or breakwater would be constructed, which would absorb most of the waves' force. The proposed breakwater would be 200 meters long and created by extending the existing breakwater built for Bandra-Worli Sea Link. Based on the hydrographic survey of the seabed and the waves carried out in the beginning, rocks of various weights and size would be acquired from nearby quarries and shipped to the site either by land or by sea for constructing the breakwater. First, the core of the breakwater would be laid by dumping smaller stones, 1 to 500 kilos, using bottom opening hopper barges, BOHB, forming a heap structure. The core would be surrounded by an underlayer consisting of larger stones, 500 kgs to 1 ton, to protect the core. The underlayer would be further protected by the main armor, which would be made up of even bigger stones, 1 to 3 ton. The armor layer would act as the primary speed breaker for the oncoming waves and absorb most of their energy. Under the guidance of divers, each stone would be placed through cranes one by one in a sequence to ensure interlocking. The 200-meter breakwater would be completed in 400 days and thus protect the Bandra port from gruesome force of Mother Nature and provide tranquil waters around the jetty area. Pontoon and link span. After the construction of the deck is complete, ramps that serve as docking points for the ferries would be provided. For this purpose, 6 pontoons would be placed next to the deck. These floating pontoons would allow passengers to get on and off the ferries. Each pontoon would be connected to the deck by link spans or drawbridges, which would tilt up or down depending on the level of the floating pontoons. The pontoon and link span fabrication and installation would be completed in 300 days. Hoverport. Besides docking area for catamarans, the Bandra port would also have a hoverport terminal for landing of 2 hovercrafts at a time. The hoverport deck construction would involve reinforcement binding and concreting, which would be completed in 125 days.
Terminal building. The terminal building at the Bandra port would be located on the reclaimed land, and its construction would begin once the land piling work by Gantry 3 gets completed in the first 4 months of the project. The terminal building would be a 2-storied steel frame structure with reinforced concrete panels. After the RC foundation work is laid, the building structure would come up using reinforced steel, and concrete and external walls will be constructed with the associated beams and slabs. Equipment such as tower cranes and mobile cranes would be deployed for the construction of the building, and concreting work would be carried out by concrete pumps. Anti-termite treatment would be carried out in the entire terminal in accordance with the best practices and specifications. To give the terminal an ultra-modern look, structural glazing would be done along the whole perimeter of the building. Inside the building, 4 ticket counters would be provided along with the necessary IT systems. Supreme Dbm Combined would also undertake construction of basic amenities within the building, including electrical fittings, concealed plumbing and drainage system, firefighting system, vitrified flooring, heating, ventilation and air conditioning (HVAC) system. The terminal building construction would commence from the 4th month and the building would be ready in 420 days.
Parking and road. Outside the terminal building, a 5,000 square foot parking area would be provided with parking space for up to 100 vehicles. What is the use of a port if it is not easily reachable? Hence, to allow easy access to the Bandra port, we would construct 16 feet wide concrete road stretching between point A and the terminal building. Traffic diversion. The location of the project site is below the Bandra-Worli ceiling, and as such, the construction work would not interfere with the traffic movement in the region. Additionally, we plan to carry out the transportation of materials in a manner that minimizes public inconvenience by efficient scheduling of truck deliveries during non-peak hours or night time whenever possible. Navigation aids. Once the terminal building and the jetty construction is completed, navigation aids such as channel markers, signaling systems and control room would be provided to ensure precise movement of ferries around the Bandra port. Word on safety and quality assurance. We at Supreme Dbm have always been committed towards maintaining high standards of quality in our past projects and would put in place rigorous quality assurance checks during the construction of the Bandra port. Highly qualified QA teams would monitor each step of the construction, ensuring quality of the highest standards. Just like quality, following strict safety measures has been our hallmark, and we are proud to say that our past projects have witnessed zero fatalities. We would continue to provide a safe and healthy work environment to our workforce by eliminating or minimizing the hazards that can cause accidents and injuries. Testing and handover. After all the construction activities are completed, the Supreme Dbm joint venture would perform thorough testing of all the facilities at the Bandra port before finally handing over the project to MSRDC. The Bandra port construction would require meticulous planning and precise execution, and with our experience and zeal to excel, we are confident in making it a grand success. The completed Bandra port would form a vital part of connecting our island city through sea, thereby making commuting easier for lakhs of Mumbaikars. And we at Supreme and Dbm are honoured to be a part of this ambitious endeavour that would transform Amchi Mumbai into a well-connected city of the future.